Hey there, and welcome. You ever see a small number just kind of floating next to a bigger one and wonder, what is that all about? Well, think of it like a secret code. And today, we're going to crack it together. Let's jump right in. So, you might see something that looks just like this. 5 with a little 4 up top. And yeah, it can look a little confusing at first. But what is it really asking? This is exactly the kind of thing we're going to figure out. Okay, here's the game plan. First, we'll figure out what an exponent even is. Then we'll practice with whole numbers, move on to decimals and fractions, figure out how to compare them, and wrap it all up with a handy toolkit you can use anytime. All right, first up, what is an exponent? Let's pull back the curtain and see what's really going on with these numbers. I promise you, it's way simpler than it looks. And here's the big secret. An exponent is really just a simple instruction. The big number on the bottom, we call that the base, and that little number up top is our exponent. All the exponent does is tell the base, hey, multiply yourself this many times. Really, it's just a shortcut so you don't have to write out a super long multiplication problem.
So now that we know the rule, let's actually put it to work. We're going to start with the basics, with plain old whole numbers. Get the hang of this, and the rest is easy.
Hey, look familiar? It's that mystery problem from the very beginning. Now that we know the definition, we are totally ready to solve this thing. Let's do it. So let's break it down. Our base is 5. Our exponent is 4. So the instruction is pretty simple. Multiply 5 by itself 4 times. Now the one thing you have to remember is that this is not 5 times 4. Nope. It's 5 times 5 times 5 times 5.
And when you multiply that all out, you get 625. And that's it. You just solved your first exponent problem. See? Not so scary after all.
Okay, so we've got whole numbers down. But what happens when we start using decimals and fractions? Does our simple little rules still hold up? Well, let's find out. Our next challenge is 0.4 to the power of 3. I know, the decimal makes it look a little more complicated, but let's just trust our process and see what happens. And would you look at that? The process is exactly the same. The base is 0.4, the exponent is 3. So what do? We multiply 0.4 by itself 3 times. We don't have to learn any new rules. You multiply that out and you get 0.064. The main rule didn't change one bit. So the big takeaway here is that the type of number doesn't change the process. And fractions, you guessed it, same exact idea. If you've got 2/3 squared, you just multiply 2/3 by 2/3, which gets you 4/9. But there is one tiny little twist you need to know about when you see mixed numbers. Okay, this right here is where people can get a little stuck. A number like 1.5 squared. It's not hard. You just have to do one extra little step at the very beginning to make your life easier. So here's the trick. Before you do anything else, you have to convert that mixed number into an improper fraction. Just multiply the whole number by the bottom of the fraction, then add the top. So for this one, it's 1 times 2 plus 1. That gives us 3. So 1.5 is the same as 3/2. Once you've done that, it's the same old process. 3/2 times 3/2. And that gives us 9/4. Or, if you want to turn it back into a mixed number, 2 1/4. See? That little conversion step at the beginning is the only trick to it. All right, you have totally cracked the code for solving these. Now, let's put those new skills to the test and use them to compare 2 different expressions to see which one's bigger. So, which one do you think is bigger? 5 squared or 5 cubed? Now, you could just guess, but the only way to know for sure is to actually solve both of them. Let's just break it down real quick. On the one hand, 5 squared is just 5 times 5, which is 25. On the other hand, 5 cubed is 5 times 5 times 5, which is 125. When you lay it out like this, the answer becomes pretty obvious. And there it is. 125 is definitely bigger than 25, so 5 cubed is our winner. Easy as that. Wow, we've covered a lot in a very short time. So before we go, let's put together a simple toolkit, just the essential rules you need to remember. Here it is, your entire exponent toolkit. Number 1, an exponent is just a shortcut for multiplication. Number 2, the rule is the same no matter what kind of number you're working with. Number 3, if you see a mixed number, always convert it first. And finally, if you need to compare 2 expressions, just solve them both and see which is bigger. That's really all there is to it.
So look, you've completely mastered positive exponents. You know what they mean, and you know how to solve them. Which leaves us with just one really interesting question to think about. What on earth happens if that little number up top is negative? What kind of instruction could that possibly be?